In this video, we're going to continue our look at hypothesis testing, concentrating on the method which uses the finding of the critical region. So, as our first example, we're going to consider the case of a factory where in the past 98% of the output from a production line has passed quality control. After a cost-saving change to the production line, the manager wishes to know whether there has been a reduction in the quality of the output. He suggests that a random sample of 30 items should be tested for this investigation, and we've got to determine the critical region for a 1% significance or hypothesis test based on a random sample of 30 items. And once we've set the significance test up, we've got to carefully state the conclusion that will be made if 27 out of the sample passed quality control. Now we want to recall from the previous video the key steps that are used in setting up a significance test. So we've got to define the variables first. Then we need to state the two hypotheses. Then we've got to describe fully the test statistic and give its distribution. We need to state the significance level of the test and whether the test is a one-tail or two-tail test. Then we calculate the critical region, and finally we state the decision rule and apply it to the data, giving a conclusion in context. So there's the information about the question again. So our first step, we need to define the variables. Well, what we're interested in is the probability, the percentage of items after the change in the manufacturing process that will pass quality control. And if we're dealing with percentage, we can equally well deal with the probability. So we're going to let P be the probability that a product made after the changes is accepted by quality control. First step then now is we must state our null hypothesis and our alternative hypothesis. The null hypothesis is the one that must be a precise statement. Our null hypothesis is simply going to be that there has been no change in the percentage or probability of an item passing quality control, so that P is still 0.98. Now the manager wishes to know whether there has been a reduction in the quality of the output. So what we're worried about is whether P might now be smaller than 0.98. So our alternative hypothesis for this test is going to be P is less than 0.98. Next step, we must describe the test statistic and give its distribution on the assumption that H0 is true. Well, the sample that we're going to be taking is 30 items, and the test statistic will be the number of products in this random sample of 30 products taken from the production line after the changes, and it's the number of those that pass quality control. If the null hypothesis is true, then we can say that X will be binomial with n equals 30 and P equals 0.98. Now there are some underlying assumptions there that the sample that we're taking is a proper random sample. Next step, we need to state the significance level of the test and whether the test is a one-tail or two-tail test. Well, the question has most definitely told us that the significance level that we are to use is 1%. And because we are only going to want to accept the alternative hypothesis, if the value of x is surprisingly small, then it is a one-tailed test. So we must now calculate the critical region for the test, and the critical region will be a tail to the left whose probability is less than 0.01. From our calculator, or from tables if you've got them available, and you probably haven't got tables available for n equals 30 and p equals 0.98, so we'll need to use the calculator. For the binomial distribution with n equals 30 and p equals 0.98, the probability that x is less than or equal to 28 is 0.1205, which is definitely bigger than 0.01. The probability that x is less than or equal to 27 is 0.0217, which is still bigger than 0.01, but the probability that x is less than or equal to 26 is 0.0029, which is less than 0.01. So we can say that the critical region is x is less than or equal to 26. So we can now state the decision rule for the test. So the decision rule for the test is that we accept the alternative hypothesis if we are in the critical region. In other words, the value of x is less than or equal to 26. Otherwise, we state that there is insufficient evidence to reject H0 in favour of H1. In this particular case, the sample that we had gave us a value of x which is 27, which is not in the critical region. If we're not in the critical region, we're going to say that there is insufficient evidence to reject the null hypothesis, and we need to state the null hypothesis in this case fully and in English. So there's insufficient evidence to reject the hypothesis that the probability of a product made after the changes being accepted by quality control is 0.98, in favour of the alternative hypothesis that the probability is less than 0.98. Bit of a mouthful, but it does need to be done fully when you make your final conclusion. Now, it's always worthwhile being aware of what mistake we might have made in this particular case. And in this particular case, the mistake that we might have made is the mistake of accepting the null hypothesis, which is what we've done, when the alternative hypothesis is in fact true. Let's now move on to a second example. During 2019, a large survey was conducted to discover what people thought was the major threat to the future of the human race, and 73% thought that climate change was the major threat. During the autumn of 2020, in a survey of 50 people, only 28 said that climate change was the major threat. Use a 5% significance test to investigate whether this suggests there has been a change in the proportion of people who believe that climate change is the major threat. So another significance test to do, and we're going to set it up again using our steps. So initial step, define the variables. So we're going to let P be the probability that a person chosen randomly in 2020 says that climate change is still the major threat. We need to state the hypotheses. The null hypothesis is the one which we will be doing all our calculations on. The null hypothesis is going to simply say that there is no change in the proportion who say that climate change is the major threat. In other words, the value of P is 0.73. The alternative hypothesis in this case, and you need to read the question carefully, and it's asking us to investigate whether this suggests that there has been a change in the proportion of people who believe that climate change is the major threat. And because of that, our alternative hypothesis is that P is different from 0.73. We're not saying that P is bigger than 0.73. We're not saying that P is smaller than 0.73. We're saying P is different from 0.73. The test statistic is going to be X, which is the number in a random sample of 50 chosen in 2020 who say that climate change is the major threat. If the null hypothesis is true, then we can say that X has the binomial distribution with N equals 50 and P equals 0.73. Now, it's important to realise that we've made a modelling assumption at this stage, and again that modelling assumption is that the sample is a genuine random sample. The significance level of test is 5%. Since the alternative hypothesis says that P is not equal to 0.73, we need to accept the alternative hypothesis if the value of X is surprisingly high or surprisingly low. So it's going to be a two-tailed test, and this is the first time that we've had to come across a two-tailed test. So we're going to see how to handle that now. So in calculating the critical region for a two-tailed test, the probability for each tail must be at most half of the significance level we're using. So when we're setting up the critical region for this test, the probability for each tail must be at most 0.025. And we need now to go on and actually calculate the critical region for the test. And we need to realise that the critical region will be of the form X is less than or equal to C, or X is greater than or equal to D, where C is the largest value satisfying the probability that X is less than or equal to C is smaller than 0.025, and D is the smallest value satisfying the probability that X is greater than or equal to D is again less than 0.025. So first of all we'll try and find out what C is, and using our calculator we get the probability that X is less than or equal to 30 is 0.0314, which is bigger than 0.025, and the probability that X is less than or equal to 29 is 0.0155, which is less than 0.025. So we can say that the value of C is 29. For the other tail, we can say that using the probability that X is less than or equal to 41 is 0.09497, which tells me that the probability that X is greater than or equal to 42 is 0.0503, and that's too big because it's bigger than 0.025. The probability that X is less than or equal to 42 is 0.9772, which tells me that the probability that X is greater than or equal to 43 is 0.0228, which is smaller than 0.025. So the value of D that we've got is 43. So the critical region for our test is X is less than or equal to 29, or X is greater than or equal to 43. So that's my critical region. So we can now state the decision rule. If we're in the critical region, then we accept the alternative hypothesis. Otherwise, there is insufficient evidence to reject the null hypothesis in favour of the alternative hypothesis. In this particular case, we had X equals 28, which is in the critical region. So there is significant evidence at the 5% level of significance to accept the hypothesis that there has been a change from 73% in the proportion of population who believe that climate change is the major threat. This stage now, we need to just have a brief discussion about the difference between the significance level of a test and the exact significance level of a test. The significance level of the test is that level of probability that is deemed to be so unlikely to occur under the assumption that the null hypothesis is valid that we decide instead to accept the alternative hypothesis as a better explanation than the null hypothesis. And the significance level is often, as we've seen, set as either 5%, 1% or 0.1%. The exact significance level of the test is the probability of obtaining a value in the critical region when the null hypothesis is actually correct. And this can be deduced from the calculations that we have already done. So, for example, with our first question on this video, the probability that we are in the critical region when the null hypothesis is true is the probability that x is less than or equal to 26 when x is binomial 30, 0.98, and we've seen that that is 0.0029. So for this test, the significance level of the test was 1%, but the exact significance level of the test is 0.0029 as a probability, or as a percentage, 0.29%. Now, for the second example that we looked at earlier, we can say that the exact significance level is 0.0155 plus 0.0228, which gives me 0.0383. So in other words, we've got 3.83%. So the second example had a significance level of 5%, but the exact significance level as a probability was 0.0383 or 3.83%. Finally, we have two comments to make about the exact significance level. First of all, it's always going to be less than or equal to the significance level of the test. And the second thing is the exact significance level gives us the probability of accepting the alternative hypothesis when in fact the null hypothesis was the correct hypothesis.